we need to know what software architecture is all about. In fact, you have at least one owning in IT or software culture. What software is, many are from other disciplines we need to make a culture in systems. So architecture becomes very important to you. And we go. So in the session, in fact, we're having two sessions today, session 1 and 2. We go on for 2 hours. At 1 o'clock, we'll take 2 more short breaks of each. And that's it. Software architecture is what we need to know about structures and views, we need to know about patterns, and then we need to know what is good architecture. You automatically have an overview of what to cover in the course of this course. So architecture, you have a system. You know, a system, well, in architecture, the architecture could be good, it could be bad. If you have a bad architecture, doesn't mean it's not an architecture. And the documented, it may not be documented. The architecture. And you need to present the architecture, but when you present it, it has to exist. So it exists. It exists for structures. I explain to you a little later. Is about the human body. Human body, you can see these fingers physically manifest, so you can take a photograph and present it. So this is what art looks like: a human being, 2 hands, 3 eyes, 2 eyes, nose. So it falls into a pattern, and when you see it in that pattern, you say this is a human being. But then you have been knowing just the actual structures. You have got a more specialized interest in the human body. Yes, so you want to know the part of the body. As a physiologist, you are a specialist. You're a psychologist. You know the circulatory system, so that's the structure. The circulatory system is a structure. The skeletal system is a structure. Is a structure. The is a structure. So these are the structures of the same system. And structures make up the architecture of the system. Now, it's made up of elements. And since we're talking about software architecture, not human architecture, software elements, a human being, you have human elements, the kidney, the heart, the fibula, cortex, all sorts of I may be there, but you don't bother about them because you are talking about software architecture. It's a software elements. And what are software elements? You're aware of this could constitute some control on the screen. They could constitute some connections made to a database. They could grids. There could be a database itself. It could be a system for searching data, searching text. All make up. Now, or relates these elements with each other. So all elements have got to have a relationship. The heart is a very complicated relationship. The heart comes from the stomach, maybe. But this is between structures. Within the structure, the arteries and the veins, they are related to each other. Salts would each other. Input to each other, dependencies on each other. So they have a relationship which should get them to work together. Understand architecture, you've got to understand the properties of these elements. So if you understand the properties of the elements, you have not understood the structure. And if you have not understood the structure, you have not understood architecture. This is what architecture is. So very you've understood. This is not about coding. This is not course on coding. We are going to be writing code in Sharp or Java or V or Python or whatever. No, that's not a part of this course at all. We are working with bundles, elements, components that will interact with each other. And change. It works at a control level. So, some critical things that an actual decision to a related field. Let's talk about a building. You make a farm, it ever got constructed. Visualize it. And the visualization, those 4 minars came up on the side, the symmetry, the component came in, the force that was deployed, allocated to various parts of the hub. We have the Harvard Bridge. Great structure, calculus. A vehicle engineering genius to balance the load on and cross the gap. And at that time, it really genius. But in the architecture, the vehicle engineers sat down and they thought of the angular moments, the linear moments, the coordinates, how much force, what material to use, the tensile strength of the steel involved, where to do the bolting. Everything else was decided later. And there, it went construction, where construction people got into the nitty-gritty of put the bridge together. Okay. All decisions that are made early are architectural decisions. Well, at that time had to fund a bridge. That's not an architectural decision. The river flow had to be diverted, not an architectural decision. So, number of decisions are taken early. Not everything is an architectural decision, and we architects are concerned with the decisions. You have somebody called a project manager. Projects other decisions or gets involved with them, but the project manager works very closely with the software architect because the architect are going to determine the decisions of the project management team. Your decision: do I use data? Do SQL Server? A decision. Now, often not very easy to decide which decisions are major and which are minor. Actions are taken by very wise people, people with enormous knowledge in study. What we're going to start doing now. Decisions and try to figure out what need to be made, you may use. Place to start is try to identify structures which make up the system. And the structure, the elements that make up the structure, and go and know what decisions that you need to take. This, again, we'll be looking at software architecture in three major categories. Module structure, we divide the entire application into modules. Let us take an example. Of accounting system. Okay. Accounting system for a point of sale. What is the sale? The sale is actually transacted. You pick out of things, dump them onto your bag, onto a bucket, or maybe a trolley. You bring and you have to try the sale. Now, sale is transacted. There's a screen, there's some you fill them up, drop down, select them. You start, click enter, it tells you what money is to be paid. You pay that, and it tells you the balance, the drawer opens up, you money, and it's done. The software you need to develop. What this into? And then we one module, sale thing, use the screen, I'll write a program. Somebody says, oh, I've done COBOL programming for the last 30 years. I'll write a program in COBOL, it will get done. It is in C# and no problem at all, I'll save the data. Then, is it? Let the architect come and take a look at the situation. The architect says, okay, this company, it has a large number of malls all over India, various stocking locations. We need to have a centralized database, and if a centralized database will not be up to the mark, I may have good availability because internet connections in India are not all good. I'd like to have real servers. And okay, I'll configure it as a proxy where keep all the current data local, and local stocks will be there, but interact with the back server periodically to update it. Okay. Then I have a back-end business logic layer where I will keep the business logic, and this logic will be stated into inventory, in close. I have thing for which I will use some third-party resources. The calculation, the famous company in Jaipur, which is a very good in-tax calculation, and they keep it absolutely up to date as per the tax laws of the country. So avail the services of that place, and then to link up with anybody else. Oh yes, I need to link up with the banks because I will allow online transactions, debit, credit cards. Okay, so that linkage is also required. Up with the local stores, automate image for stocks. When stocks start running, okay, do I have to do it in the system, or do I have a separate module for that? No, and as it goes on and on and on, and there's so many decisions to be taken. And okay, the folks, let's have the architect decisions, and then let us know we'll do the coding. There are teams of coders. Somebody is going to code the database, somebody is going to code the player, somebody is going to code UI. And this model has made a special facility where they allow you to browse on a mobile and locations where the products are lying. And if you don't want to pick up the location, you just say, put it in my shopping basket and you click select for me, and there's a special marketing representative of the store who actually goes around, picks up everything and brings it to your shoe basket. Okay, fantastic. Who thought of it? Some guy in the marketing department has overnight and he's got this brilliant brainwave. Okay, let's take note. How important is it for the bills of the company? Let them call in them people to figure out what incremental business they will get by having this type of model put up. They are the business decision makers, they are the marketing people, they are the product people who will be actually looking at the code happening. These people will have to understand the software and they make up the entire system and break up into modules. There are small modules, maybe, or very big modules, the larger modules. There's one. Let's go on. Okay. I just looked at the chat and I think that the people here who are really concerned about that book, the content, and early in the day to start getting worried about the examination. I know you are very busy people with work to do. But one course, you can just very to early pass because people normally will not score very low here. Because you know the subject. At the end, are subjects where you will be getting very high scores. You win scores in this course in spite of believing that you have given an excellent answer. That we have a panel of faculty who are very senior with experience and who is stingy on marks. They don't give marks very easily. So don't get worried because you are probably new students with the BITS and you are not aware of the system at best. BITS has a system called relative grading. And grading system, grade is supposed to be a very good grade because you are not participating in this course in the midst of a whole lot of stupid people. Yeah? You got intelligent co-participants, and the average with intelligent co-participants, well, you are good because the average here is good normal standards. External deviation from the average gets you a grade. Anyway, that said, what I would like to warn you in this course is that to focus on the examination difficult because a course is really leave much room focusing on an examination because this is a course really carry your career in software systems because it's understanding of architecture that determines where in your career if you're software systems. You got an architecture. And recommendation to any student doing this course is don't bother about the examination and a lot. Learn about line and the textbook. There's a resource available which will probably explain to you during the orientation session. I will just brief you once again. It is with-planning.ac.in. On the screen here. Those. And if that you have not gone to a particular page, you're doing a very big mistake. Page, there are 2 pages for particular course. And for nature, I just do for a visit to this page, and though a little differently for you than for me, but so I'm going to share my desktop and this particular page. Here you are. .bits-pani.ac.in looks like. My courses in which you are involved. And the courses where my list, they will not appear in your list. And this will be active. Besides, they will find a courseware page of architecture. On this, a related material which is into textbook. If you hear new material and into the software architecture, here all those you can VIGS gives you a choice of two faculty, one who talk to you live and you can interact with, and a person who has placed a set of recorded lectures and they simply sub each other. So it should both, because there's things I may not emphasize on, because the pace in my lectures are going to be a little slower, whereas a person is undisturbed, he is just gone ahead like a textbook and lead you on the subject. So parallel lectures and his slides have also been provided here. So lots of material over here. Go through it. As this, the page appears here. And goes to topic 1 today. But 2 to 3 is the recording of this particular lecture, including what I'm saying just now, are going to appear under topic 1. Up and out. Click on this. It and out. That is the textbook, the reference books, the reference material, the progress of the course. Done, everything is given over here. So this particular course handout goes what are the textbooks that are needed, the reference books, the cover, then wise. Today we are going about the first and the second section. Like you know, the sessions are listed. And so we divided into 2 sessions. Let me get to the course. I did first to know whether the handout is up to date. Well, you were a reason for asking this question. What believe it is not? No, nobody will say this is the final handout. I would like to know what makes you believe it is not. You must have found some defect in the handout. We believe that this may not be or may not be the final handout. Session. Somebody said in the last session you were given a different handout. Somebody else took a lecture for software architecture in the last session. You're to other subjects. Okay, let's discuss only software architecture in this particular. Please leave we'll leave that to the process. Okay. In those we have it out, so let's keep it. Okay. Let's get back to where we are. So you have a textbook, you've got your handout, got the layout. Assignment in this course is going to be very interesting, so I'll give you more information on the assignment. And this course, you'll do a lot of work without getting any marks for it. Now, that would be different from maybe some other courses. Because I believe that you want to become software architect, you don't want to become just an A grader in this course called software architecture. That's very easy, by the way. This is so easy to get marks and pass the exam. So let's think it. That's already done. By what you're having entered here, you're clearing is assured as you give a little bit of time. I'll give you the detailed calendar. No calendar with you. In fact, I have it over here. Let me pause the recording. Go to view and let's see. It's off, I guess. It is there. Yeah, it's attended. So we don't have any class last Saturday. We've got a class today. Next Sunday we'll have class. No class, and then there's Rakhi. And then Saturday, then there's a class on Saturday and Sunday, and I'll share this with you, don't worry. The class on Saturday here, again on a Saturday. So, the one, the buffer, if we are not doing enough and we want to have some additional mileage, we'll put in this buffer class. And that is cut off like this, a buffer with a cutout. All these buffers are cut out. Otherwise, I'm considering not having a class, but at short notice, we may decide to have a class. I've got some faculty members with me. I would also add some sessions to give you some skills, because there are certain skills required to pursue this course. So we can get some of my co-faculty members. Now, viewers and have out that I intend to have at least 2 buffers utilized. This has got 22 sessions, 2 days are enough to cover the course. Give you an idea and listen to your recording, and the overall master schedule given to us by IITS as how the 8 slots they have provided for the course, out of which we require to take only 11 for this course. The pre-recorded material where 16 classes are required, so they have 2 extra slots for that. So, give an idea about how this course will proceed, and I will share this sheet with you separately on eLearn. It will go up on eLearn. Okay, so I think I've taken care of all the is normally uploaded after this. And for example, it's provided to the this department by us in advance, but they send to you when the course is over, class is over. But if you have an idea of what will be covered, you can go by the course handout. The course gives you a very good idea what's covered. It gives you know part of the textbook you should be looking at. It gives an idea of the previous lectures you should also look up before coming to class. So there's a lot of indication given in the course handout. Do follow it. And the module structure, and then you have the component connector structure, and then have the allocation structure. Since we take the software it up into blocks, component connectors is we take the entire software system, we break the components which can work independently. A server could be a component, a mail there could be a component, and EP could be a component, and the connectors, how they connect to each other, and what is the communication protocol, and what of information, and relation structure. We decide how to allocate various software components to hardware components. You have to add that. Also, how to allocate manpower to development resources. Any type of action of resources to what is the allocation structure. we'll bring back to these structures. There are questions coming here. I'm going to address them during the next session because I would not like to divert out too much. Now, let's spend a few minutes on the module structure. We take the entire system and we simply break it up into implementation separately. Separate workers, computational requirements, or they could have given to separate programming teams to develop. And modules, big modules, will be divided into smaller modules. So, this structured approach to development, where you, in a program, you develop it into subroutines and subprograms, but when it's a large software system, you break up into small components. So, this type of a breakup structure is called a module structure. We go into more details of it in the future section. Now we go to components and connectors. Now, these are provided by which maybe you have them as modules, but when you component, you're not looking at a number of modules put together may make a component. And these say you want to put an amplifier. The component of an amplifier would be a transistor, some resistor, some condensers. They act independently, but they're connected by wires. Or you have active elements connected through passive elements in an electronic circuit. In a software system, you might have two connected over HTTP protocol, over TCP. They will be connected, wired together. They will be running synchronously on the same machine. They may be running asynchronously on the same machine. So these type of elements of the system, how they run and how they connect to each other, something we look at component connection structure. Again, you'll see various component and connection structures. And of the pre-recorded lectures, the faculty has given it. You can use it also. We see type of component connection structures and different module structures and get a better idea of the difference between them. Now, the tools environment. It could be the hardware environment, it could be the people who will be developing, the people who will be installing the software, the people running the software. You have an examination system where we have an administrator, paper setters, supers handling the appearance, and the elements of the software system may be allocated between these users. I may use an administrative module where he registers students, allows them to appear for an exam. The paper setter may have a module where he sets the paper and saves it in a repository. The monitor questions set by the paper setter, vary their correctness, and place them into the become a part of the data or a part of question bank. So the appearance, there is software on various machines, them available for the candidates after logging in, so the candidates may log in and appear. So they are separate application set, and appearing has an appearance module. It starts the appearance module and it appears to them and logs off any. So the elements of the exam have been allocated to various types of users, and this structure would be useful because you could design them depending on the type of requirement. You can take a development team that would be a structure. Once you put together a few modules and you have a component, the components may be deployed on various platforms. Like a very specialized Linux box a component called an RDBMS supplied by a could be a component in your entire system with a number of modules. So this is where you should be able to describe. Now, are structures architectural structures? Now, those will help you to reason about the software, the property of the software, which will follow architectural structures. You have a building and you of the structure. Is it an architectural structure? Well, yes, if the it was told in the beginning that you're designing a infrastructure in which we intend to provide a bed, two sides to the chair. So the architect has to provide that position. But after you've done it, the way you will rearrange these chairs in that room is a part of architecture. First time, I'm concept of stakeholders. Yes, and here we'll have to do a lot with stakeholders. Stakeholders are the people who help you determine what is architecturally significant. The outline, what you do achieve with the system, ability you require, what difficulties people normally face, and you would like to difficulties, what response you require. All these sort of things are basically collected from the list. That and is an abstraction. Who in object-oriented environment have some sort of an abstraction. And okay, just these questions in tandem together because I want to keep a certain flow going. When I talk abstraction, perception in the mind tells me where things fit in. Architecture becomes an abstraction of physical system. As if it exists into data. When you see a system as an abstraction, use complexities. You see it as something simple. And you use these complexities in use. Like, okay, this module, now how that module handles, let's not bother about it now. We'll get to it later. We'll do it when we develop the module. We'll do the programming details. For example, in the examination system, intend to while is appearing intervals. Now, how do it? How do we? What are periodic intervals? When the photograph will be taken? How to save? Where to get saved? We'll talk about it later. We really decided there's a module called photo. What it is? It can be a cab driver. It has some sort of a sensor. It has a connection with a database. Keeping track of the progress of the exam. So, this is connected, this component called the camera is connected with allocation. Certain modules to manage the camera, to manage the examination. So, all abstractions which help you to think about the system at a simplistic level and leave the details for later. I've mentioned that I started off, and when I started off, we hardly had some 70, 80 people here. We've got 13 countries who are on. So, as we know that every system has implemented, it may not be good, may have been lost, it may not be available. I'm getting my voice a bit fast, right? Okay. Yeah. Every system the chat box. What about the mobile phone? Let's talk about Android. Android system which powers phones from a large number of manufacturers all over the world. So, like Linux as a kernel, how winds of the mobile device to be used. It has capabilities of graphics, camera, sound, video, and with the bottom layer, it is the entire working. The moment a software person knows this, he's now in a mood to write applications for Android, and he knows what happens in this box. It's an abstraction. It's not the physical stuff. A general of what Android environment is about. So that now use code of and does not mean you have an architecture. You wish documentation exists for someone, but it's also possible that well, the documentation. So what? Does it mean that there is no architecture for Android? Who say Symbian or iOS or Microsoft environment think that is a bad idea. It's a bad idea. It's all right, and it's not a solid, robust architecture. So this is the idea of what architecture is. So say that there is an architecture. Whether it is required, not required for later, well, we are in this industry, we know that documentation plays a very important role, and we will divert into talking about Agile and so about documentation Agile. We'll talk about all that later. Does behavior connectors each other in aspect of the architecture. Certain mode of behavior has got to be recorded. Aspect of the behavior of a software system is you would be doing another course parallelly with this course called Object-Oriented Analysis and Design, or fine-grained work of designers and not the architects who get into the fine-grained level of the behavior of a system or its components. So you need to understand, because very often people ask, what's the difference between design, architectural design, and that is design, system design. And code is going to be written based on architecture. You make decisions on what modes you will have. Now, to make qualitative judgments about architecture, we need to have a few more classes, and we will understand what an architecture could be. Now, I give you the example of structures that is physiologically. I'll pass over this slide now, because This has got nothing to do with software. Here, features, just you have different structures, logical aspect of a human with now, you have within the structure so that people can understand it. The of a structure for people is called a view. To prepare, represent structure through views, and that's going to be a part of this course. This of drawing, which extent the tools available in object-oriented analysis and design could be used while building architectural structures, but tools used in software architecture are more of a course nature. So we're getting into some of those. Now, a while back, that we'll be getting into a little more detail about module. That you determine certain responsibilities to each module. Maybe using other elements to execute their work. There can be a relationship between modules of each other, or depending on each other, or collaborating with each other. These modules could also use the oriented concept, organization and specialization, which we will study in other courses. I won't get into details here, but generalization and specialization basically says that there are some commonalities between 2 or 3 modules. Each module which has the common factor is something like this. Those of you who are more mathematically inclined, if somebody gives you an expression called xy, to put it down as x in y plus z. This expression gives you a very good idea of generalization. If 2 modules, one perform the function xy and the other perform function xz, it would be an idea to split x into a module we call generalization. Y are made as specialization so that you there's only one. You cut chances of errors and you have a structure. A little more to do with the runtime aspect of the system. Well, components that actually work, which are identifiable each other, some data in a common repository. Then them used all over the place. They use just to present, and they run parallelly, or they can synchronous or asynchronously. The meaning of synchronous is synchronous in the dictionary, but speaking, synchronous is both running independent, depending on each other. March past, in school, where in the army parade, when they march, they are synchronously. And asynchronous, when you are in the mall, you are loafing around, you are asynchronous. So you can run synchronously, the components can run synchronously or asynchronously, have the advantages and disadvantages. And also have system structures which dynamically realign themselves with one another. Somebody they did not see when I typed XY plus XZ. Okay, I will page once again. If I have typed something and it's not getting fetched on your machine, just control and Y. You have to pull the data. That's something I know do a shift control Y to push it, but you can also pull it. Next structure on which I have spoken adequately is basically at runtime or development time or testing time or addition to teams, addition to hardware, or allocation to the time available on a given source. So these are allocation structures. These structures help you to think about the system. So the structures are there. That's why you look at structures. Bring you to a very important aspect of software architecture. I'm curious that, okay, what's the difference between an architect and a designer? A designer goes fine-grained aspect of a system. The fine-grained is actually coding. When you write a code in C#, that's actually fine-grained. When you write an outline, using a diagram, a class diagram, or you're writing a diagram, those slightly less. And when you're talking about a box as a server, a box as a view, a box as a controller, these are code-grained. These are architecture. Now, is the important contribution of architecture to software systems. So, architecture, listen to this very carefully. Software architecture provides the attributes to what is availability, security, testability, modifiability, scalability. As ones we are going to discuss in the course, but if you go into the complete ET, you have about 50 of them. So, in this, we'll see the major quality attributes and see what is and what tactics we adopt to provide the right quality attributes to the stakeholders. I say stakeholders, very important. About quality attributes, very important. And software architecture is a course about quality attributes. We deliver quality attributes to this year, and we would like to take a few minutes and come after the break.